Hi, everyone. Thank you for joining our talk today, CloudBees Securing the Software Supply Chain with SDA in partnership with Atlassian. We're really happy to bring this conversation to you today, specifically in light of recent events around the SolarWinds incident and really thinking about taking your DevSecOps initiative and your software supply chain to the next level with security as a paramount focus to that. So I'm Tyler Johnson. I'm a solutions architect here at CloudBees. I support our federal business. And if you have any questions, my contact information is on the front page here. Feel free to reach out anytime. I'm really happy to answer this. So as we begin this, let's kind of set the focus on what the software supply chain entails and kind of relate that to the similar supply chain that we see in things like Amazon that ends up with a package on your doorstep on a weekly or bi-weekly basis, however your shopping tendencies might look like. In a traditional supply chain, we're talking factories, we're talking about transportation, we're talking about marketplace, and then we're talking about audience. The same sort of idea and concept also relates to the software supply chain. And what you'll see here in this graphic, we're talking about source code, we're talking about dependencies, we're talking about how do you integrate the work that your developers are doing in a really functional and automated way with the rest of your processes that you can see here, like Jenkins, which CloudBees is the enterprise sponsor to the Jenkins project. We really focus on DevSecOps, along with things like Atlassian Bitbucket, Atlassian Jira, talking about the networks that your infrastructure resides behind or where you're deploying your applications to, your application repository, which is the home to those built artifacts or to the work that you're going to do and process out to production environments or whatever your environments may look like. And then lastly, the final piece to that software supply chain is your deployed environment. So where are you managing this? How are you doing patches? How are you able to do real-time analytics into how your product is being consumed or your application, and making sure it's done in a secure fashion and an effective fashion as well, whether you're supporting the American civilian or the warfighter, or if you're in the commercial space as well, that's always an option. So before we get into some flaws in the software supply chain and some really common things that we need to think about when it comes to DevSecOps and how can I fortify my software supply chain, let's talk about the most recent event behind SolarWinds. So what I have here is the timeline as we know it today with SolarWinds. We don't know exactly the reason behind this. We have a lot of ideas as to where malicious software may have been injected into the supply chain and how it eventually made its way through into production, but no one is 100% certain as to where this began or honestly where it's going to end at this point. But what we do know at this point is that SolarWinds did not have what you would call a secure software supply chain, and it largely was a fault in that supply chain that introduced this malicious software into the life cycle and into the release structure that eventually made it into so many systems. And there's a reason that everyone's kind of going in a frantic panic right now to resolve those with any software that was impacted by the SolarWinds hack. Along with the timeline I have here, I would kind of like to read this quote. I think it's a really good analysis as where we are currently in the situation. And the concept is that attackers may have leveraged malware at many points along the path, or the way I should say, as code moves through the software development lifecycle. So the belief right now is that it could have been done in a multitude of different angles. It could have been done in source code. It could have been directly injected into your CI/CD platform. It could have been directly injected into an environment or into an artifact. There's a multitude of different things that could have happened, but in reality, if any of those had happened, it should have been detected, and automation should have been in place to help resolve an error or an issue or a bug from actually getting its way into production. So if we're focusing on the process, which is where we're going to spend a majority of our conversation today, and really hardening that process, supply chain hacks like SolarWinds shouldn't really happen again, and you're able to mitigate a lot of the risk that comes with the management of so many tools, so many different platforms, and in general, just the complexity of the DevSecOps or the supply chain space, because companies are coming and going so rapidly, the technology is evolving. It's important to stay on the curve, but also make sure that what you're implementing and what you're using, especially in the federal space, is very secure and very compliant with whatever standards you and your organization have set in place. So what I've done is I've taken this graphic that you see here on the screen at this point. It's just a really general kind of blank slate software delivery lifecycle. And actually, I pulled this from Continuous Delivery. It's a book that was written by Jez Humble and Dave Farley in 2011, actually. So it's a little dated, but it's a really, really good bare bones model of what a software development lifecycle would look like. And it was written by two of the leaders in the space. These two are still very active contributors to DevSecOps material, sharing best practices, contributing to the State of DevOps report on a yearly basis. If you're not familiar with that, I really encourage you to go out and give it a read as well. It's done by the Dora Group. They're a nonprofit that just goes around all sorts of segments of industry, and they start sharing and generating best practices and calculating some of the metrics behind some organizations' success and others' failures, and really showing and spreading the good word that DevOps can bring to an organization and why it can be so effective for not only the agencies listening today, but even myself. I still glean quite a bit of interesting material from the State of DevOps report, and they're really largely responsible for that. So what you see here in this graphic, the reason I really like to show it is it's got the general structures that we see in every software development lifecycle, even if it doesn't mimic yours as an attendee today directly, which I 100% guarantee it does not. There's a lot more complexity in your software development lifecycle than what you see here. However, what you see here can easily be conveyed over, or you can kind of draw a line between what you're doing now and what you see on this graphic when it comes to roles or stakeholders like developers, testers, and operations you see here, commit and acceptance stages, the portion of building artifacts, testing them, making sure that what you have is a really valid release candidate in that part of the life cycle, and then how it progresses through the different environments, which in this case would be UAT, capacity, and production stages. Even though for you, those might take on a different name or a different structure. You might have different security enclaves. You might have a number of different development environments before it even gets to a QA environment. But the general flow of this should seem somewhat familiar. Along with that, there's a lot of ancillary parts to the process that are important as well. Where you store your source code that goes into your application builds, where you store your environment configuration code. And then as the world becomes more and more in tune with the idea of configuration as code and GitOps, you should also be thinking about how do I manage and control my actual tools and code behind things like Jenkins, or tools behind things like Ansible and Terraform, and all of these different components as code as well. So now we're using a flavor of Git, or in this presentation, we're specifically talking about Atlassian and Bitbucket to then be the home and the source of truth for that versioned artifact, so that you have a really consistent trail of how changes can be made, a really great approval process, and then an audit trail in which to come back on if you need to perform an audit, or if you need to do something like a rollback. So there's a lot of benefits of mentioning that as well. And then the last little bit, the artifact repository at the bottom. So as we continue this general conversation and as it pertains to SolarWinds, we kind of really want to highlight at this point some possible points of entry in this blank slate sort of software development lifecycle to where SolarWinds may have been penetrated, or where a possible point of entry may have occurred inside of the lifecycle. So the first one being maybe the code or malicious code could have been inserted directly on a developer machine. So we're talking about the developer persona here with the green arrows. We're talking about pushing that or committing that up to a version control repository, and then that's processed directly into a commit stage. So this is one attack vector that could have been penetrated in this incident. It's not the only option, but it is one that's worth considering. Another option could have possibly been that the code was changed directly in your version control system. So maybe they got direct access to Bitbucket, maybe they got direct access to GitHub, whatever that may look like for you. Maybe they have access to those repositories or organizations, however you have those organized inside of your version control system. And if that was the case, then that code via webhooks or manual tasks that then kick off builds and tests, it is then introduced into your pipeline structures and then relayed across the different environments, whether you're doing DevOps or you're doing a more manual water flow based development process. This is kind of the head of both of those processes. So if it gets injected at that point, it certainly will percolate through the different parts of the organization on its path or journey towards production. Another option very well could have been that automated processes may have injected the code directly in if the attackers had access to, let's say, the platform or the tools. If they had access to something like Jenkins or Circle CI or whatever other CI engines or automation tools you're using, they could have been used to inject malicious intent software directly into the build process or directly into the package that's being generated as a part of your development lifecycle. So now we're really talking about not just commit stages, but also the acceptance stage. We're still talking about the possibility that maybe it went unchecked and was injected directly into a version control system, thus pulled into your automated processes. So there's a multitude of different vectors in which this could actually pertain to a realistic scenario where SolarWinds was penetrated by the most recent hack. The next option, which is one that I look at and I really hate to discuss because this should never happen. And I want to reiterate that again, this should never, ever, ever happen because it should be impossible. But the idea that a QA team may have access to change the code when it comes across their part of the lifecycle. So when an artifact or inside of your software delivery lifecycle, when it gets to the point of QA and testing and it's in that environment, no changes should be made at that point to your automation engine. Nothing should be done to the source code. Nothing should be done to the artifact. It is purely a testing arena. It is a checkbox to make sure that what's done at this point is compliant and is what is expected in order for it to keep progressing down the development structures, or sorry, the deployment structures, I should say. You should not let QA testers or QA admins or whatever that role may look like inject code into the system at that point. However, this is a real possibility, and at this point, we are fairly certain that SolarWinds allowed something like that to happen inside of their development practices. May not have been the point of entry in this specific incident, but this is a problem, and it really should never be allowed. So at this point, I just want to make sure this is not to do with DevSecOps or anything else, but we should really not be following this as a DevOps practice whatsoever. But it's still a possible point of entry. Lastly, I would say that another point of entry could have possibly been that attackers got access to the servers or hosts, updating or replacing, valid deployments or artifacts with the malicious code that they wanted to inject into the system. So this means this is more dealing with the operations role. Maybe it was replaced in an Artifactory or a Nexus example, whatever your artifact management may look like. And then it was deployed to those environments without knowing that the actual bits had been swapped out, or they were directly injected into a production or pre-prod environment. This is always another possibility that could have been a hack to the supply chain that went into SolarWinds. So when we expand this out and we look at the entirety of what could have happened and all of these different attack vectors or surfaces or points of entry that could have possibly occurred inside of SolarWinds, it's a very complicated picture. And these are a lot of things that we need to manage and maintain and look at and make sure that these aren't vulnerable points of entry moving forward. However, that's not really why I'm here and having this conversation with you. It's really important to think about those points and securing them, but we really want to talk about the process. What is the developer doing? What is the tester doing? What is the operations unit doing as something moves through on its way to production from initial idea, let's say a Jira story, or an issue that may be presented in Jira, or a task, through the commit stage, through the approvals, through the testing, through the deployment to QA and on to production. That part, that pipeline that takes an origination of an idea and a commit and really drives the automation of all of those different components, that's the process that we can help you with. That's what we can do in partnership with Atlassian to secure the supply chain and make sure that even if they have accessed or gained entry into your system like this, nothing would ever be promoted into production. And kind of continuing that thought and this general idea is that we're moving away from this idea, and I don't want to belittle it at all, that you should just be focusing on the attack surface. And it is really important. You should always be securing your network. You should always think about your role-based access control and permissions inside of your version control system, as well as your environments in which you're deploying software to. However, you should be focusing even more on the process. So one is not necessarily more important than the other, but if you have a really rock solid process, anything that could get through your network or anything that could be injected into your software delivery lifecycle should be and would be detected, and it would be stopped right there in the tracks. A ticket could be filed back, and now you're back to resolving an issue rather than promoting malicious software into an actual environment, which is what happened in SolarWinds. And a lot of folks at this point are thinking that actual personnel and leaders inside of the organization knew that some of these vulnerabilities were present and chose to ignore them. If you have automation and you have checkpoints, A person cannot ignore those. Instead, they are always stopped because you have gateways and you have all this automated out to where a process detects them and they fail immediately rather than coming across the desk of a human being and them actually giving it a check mark or kicking it back to a development team. So rather than going around and chasing that kind of whack-a-mole game here from the instance here of how do I stop this angle or vector of entry and promote or secure another vector, another one would spring loose, right? There's always another way that someone can gain access into your software delivery lifecycle. So rather than just trying to plug the holes, let's focus on the actual process. And a really great analogy for that is think of your software supply chain as a bank. In your software supply chain, and much like a bank, I'm sure they want to have very secure doors and windows. That's really important. Those are the attack angles we were just discussing on the previous slide. However, they invest a lot of their money and a lot of their time in a really good vault. So even if you get in the bank, you can't get in the vault. So that's a good way of thinking about your CI/CD processes or DevSecOps. Even if you can get into my software delivery lifecycle, you can't get into the process. So even if you try to inject malicious software onto my developer machine, or you try to inject it directly into my artifact repository, it will be detected. It will be caught. We have robust systems through automation, through a multitude of different tools that you can choose to use as part of the lifecycle. And in parallel with human approvals, those are never promoted up to the next step. They're stopped directly in their tracks, and you can ensure really secure, compliant releases of your software artifacts across any number of different environments. So how do we help do that? So I think we've painted the picture, and now what we really want to focus it on is how does CloudBees, especially in partnership with Atlassian, how do we accomplish that securing of the supply chain? We've talked about why the supply chain is important and how it can be used to filter out these issues and effectively prevent another SolarWinds sort of incident. And if you think back to that graphic when we were showing, where do developers fit into this? What do they do? They're in the application code, they're in the environment code, the version control system, that can reside in Bitbucket. And then we're also talking about the commit and acceptance stages. This is the part of the CI/CD workflow where we build artifacts and test them and effectively create a release candidate. That release candidate can then go through another process of, does it get promoted to pre-prod? Does it get promoted to production? Is there more testing that needs to be done by other stakeholders? That's not the part we're going to focus on this slide, but we're going to get to that. In the commit and acceptance stage with Atlassian, what you're able to do is you're able to store a version of truth when it comes to your Jenkins jobs structured as a pipeline. You can see here on the bottom, like pulling your source code, doing a Maven build, running sonar scans, running quality scans and security scans, eventually ending in a deployment to Nexus and a kickoff of an actual release. But that pipeline itself, you can build those as templatized models inside of CloudBees CI, and you can store them and manage them inside of Atlassian Bitbucket so that one, you have a really rock solid standardized approach to how your CI/CD pipelines will be built, because you've built one reusable template for X amount of teams inside of a catalog, and you can add more templates to that catalog. And then on the flip side of that, a developer, you no longer need to worry about them setting up some sort of a Wild West Jenkins job that's introducing vulnerabilities through integrations to third-party tools, or storing, let's say, credentials as plain text, which I'm sure no one would do. We're kind of all past that point now. However, you want to prevent those. So having a standard, compliant, templatized structure to how you're going to do your CI/CD jobs, or what are referred to as Jenkins pipelines, that's a really good way of thinking about it. And now you can manage that pipeline across many different teams at scale. And if tools come and go or they change, you have that source of truth inside of Bitbucket. And let's say you want to swap out your container scanning tool from Twistlock to Anchor, which is a really quick exchange. You don't have to roll that out across multiple different teams and multiple different implementations. Instead, you can change it one time in the template. Is effectively rolled out across all of the different use cases of that template across any number of development teams. Along with that, something to add, Jenkins is the glue that drives a lot of automation inside of your pipeline. However, the individual tasks, as you see at the bottom here with the green blips, like pulling source code, Jenkins does that, but Maven is doing the build, and Sonar is running your code quality scans. Those are tools that specialize in certain aspects of your development lifecycle. they're the best in the world at doing that. And there's a reason that there's so much adoption for tools like those. So we are not prescriptive whatsoever as a solution on what tools you should use. Each organization has completely different needs and different best practices. So the ability to kind of define templates for your organization that can be reused, but also can be really flexible to reflect those best practices is really important. But those integrations themselves are driven by what's called a plugin. And a plugin is just that API call out to the tool in order to implement, let's say, a Maven compilation or pulling down dependencies from Maven Central. That is a possible vulnerability that could exist inside of your pipeline. So you want to make sure that that integration is rock solid and strong. And what you're able to do is create allow and deny lists of those plugins at specific versions. So you can always ensure that your pipelines are using the latest, greatest, and safest as you're building your actual applications. Another point that's worth mentioning, and I won't spend a terrible amount of time on this, but configuration as code, as I mentioned, that's the future. It's really beneficial because you can start taking your actual configuration for tools like CloudBees Jenkins, and you can store it as code inside of Bitbucket. You can put it through the exact same, PR model and approval process that you do with your application code. And now what you're able to do is you have a source of truth that's a versioned artifact that resides inside of Bitbucket, and it can control a lot of things like your Jenkins actual configuration with agents, with secrets, with libraries, with pipeline template catalogs. You can control the way that plugins are installed, and you can control the lists that are allowed and denied, and you can control your role-based access control, your permissions that you want to set inside of this also as code. So now you have this concept of a bundle that resides in Bitbucket that one reflects the active translation of the configuration inside of a CloudBees instance and can push updates to it as well. And then in the end state, you see here, I have the equal sign. Now your server or the configuration on it should be reflected and equivalent to what you have inside of Bitbucket. So it's a really nice enterprise way to manage and set standard practices in place for the way that you're doing DevSecOps and really securing that supply chain through Jenkins. So as I mentioned, and I told you we would get to this at some point, we need to talk about not just those compile and acceptance stages, right? That part of building an artifact. Now we need to talk about where does that artifact go and how do we promote it between environments? That's a critical part of my software supply chain. And what we use that for is called CloudBees CD, which is part of CloudBees SDA, as I mentioned at the top of the discussion. What this solution allows you to do is pull in bodies of evidence from all the different tools inside of your software delivery lifecycle, including those that live outside of the scope of Jenkins. So in this example, we're talking Atlassian, we're talking about using Jira. You can pull in your tickets, you can pull in the stories, you can aggregate or collate them into a report. You can pull in your change logs from any flavor of Git or Bitbucket in this example. You can pull in your Jenkins logs. You can pull in and parse out certain statistics or data points from Sonar or Selenium or Jacoco if you're testing with it, or JUnit. And what you're able to do is you're now generating a body of evidence that can be promoted between the stakeholders and between the environments as it progresses on its path to production. So in this example, you can see it's just a Kanban view of a release structure with release readiness, where it's pulling in all of that information, starting the construction of that body of evidence. Then it goes to QA, and inside of QA, we're doing a deployment, and we can run some the enablement of a feature flag, and we can send Slack messages to see if this is successful. We can run more tests. And then as we go to pre-prod, one really important thing that we're also able to do is we can add gate criteria. So it won't be injected or deployed to pre-prod without an approval, in this case, by a release manager that you see there as an entry gate rule for the pre-prod Kanban column. So at that point, a release manager can look back on all of the information that's occurred up until this point, all of the reports and dashboards that you can generate inside of CloudBees CD in order to make a really predictable push button release into pre-prod. And likewise, on the backside of this, as an exit gate criteria, it can never be up for an ATO or migration into production if tests or certain thresholds that can be automated are met. So a good example, if you think back to the first column here, Sonar, if not 100% of my code coverage is met, I will never allow an artifact to then move into QA. And that is not a human approval. That is an automated approval, and it's something that SolarWinds should have had in place, something like this, So it could have caught these vulnerabilities and filtered them out before they could do any harm across any number of the environments in which they eventually ended up in. So this model is not just about how do we prevent vulnerabilities, I should say, and secure the supply chain, but also how do we speed up the way that we do releases? How do we add more checkpoints, make sure that what we're doing is a really predictable push button kind of release model? It's kind of a hot term right now with the push button. And then also at the same time, facilitate in the federal community things like accelerated or continuous ATO through the generation of evidence and the ability to review those every step along the way. So we're moving away from change approval boards where they're slow, they're methodical, they're more of a waterfall sort of idea, and moving towards continuous or accelerated ATO. This is just an idea of what some of the graphics and reports you might want to generate inside of CD would look like. So the ability to track performance, continuously improve, and drive your DevOps innovation. And then lastly, and really importantly for a lot of us as we're starting to build our DevSecOps teams up, make sure that what we're doing is driving and demonstrating value. So that return on investment is critically important because you want to show how the securement of the software supply chain through DevSecOps is really driving value, whether that be reduction of risk or adoption from your consumer base or a reduction of cost. Those tend to be the three largest buckets that we're talking about when we're talking about return on investment. But you need to be, at the end of the day, with great technology driving some business value. And this gives you the insights and the way to share best practices across the teams to really exponentially grow that value. And then as we conclude here, I just wanted to point out this was a discussion and partnership between Atlassian and CloudBees, and Atlassian is a leader in the space when it comes to version control management, as well as especially Jira and ticket management and really managing your development lifecycle. And because of that, it's a really tight partnership that we have with Atlassian and CloudBees. And this kind of serves as proof to that point with the integrations we have in place with things like Jira, Bitbucket, Atlassian Software Cloud, or Atlassian on-prem if you're using that as well, Kubernetes integrations, as well as crowd integrations as well. So there's a number of these, lots of documentation and plenty of proof points across the federal community where we're working hand in hand with Atlassian to really start to drive adoption of DevSecOps and focus on now securing that software supply chain so that we can move at pace, but also move in a safe and predictable manner. So thank you everyone for attending this session, partnership with CloudBees and Atlassian on securing the software supply chain. I hope you enjoy the remainder of the Atlassian Government Symposium. Lastly, I wanted to add my information here. You can reach me on LinkedIn. You can reach me via email. If you have any questions, I'm happy to further this conversation or any other topics you'd like to discuss around DevSecOps or GitOps or just development strategies in general. I find them really interesting. So please reach out anytime, feel free, and I'd love to continue the chat. Have a good one.